This is the review for test unit 5, Pythagorean theorem, special right triangles, and triangle inequalities. Make sure you have your review out so that you are following along while we are recording. So let's look at number 1. Solve for x using the diagram below. Well, since x is the side of our triangle here, I can just use Pythagorean theorem. The 15 is across from my right angle, so I know the 15 is my hypotenuse, so that's my C. So then I would have 9 squared plus x squared equals 15 squared, so 81 plus x squared equals 225. Subtract the 81 from both sides. I get x squared equals 144. So I square root both sides to get that x equals 12. So there's number 1. Number 2, again, I'm going to use the Pythagorean theorem. I know the square root of 17 is my C because it's across from my right angle. So I know that x squared plus 3 squared equals the square root of 17 squared. That's x squared plus 9 equals 17. Subtract the 9 from both sides. X squared equals 8. So when I square root that, I get x equals the square root of 8, or 2.828. Either one of those answers are acceptable. Number 3, a drawing of Pete's kite is shown below. What is the length of the short section of the outer frame? So we're looking at this triangle right here. Sorry that we have labeled off. Well, we know that this piece here is our right angle. So we're looking for our hypotenuse this time because the x is across from the right angle. So 12 squared plus 35 squared equals x squared. So 144 plus 1,225 equals x squared. So I have 1,369 equals x squared. Take the square root of both sides, and we get x equals 37. And since we are dealing with an actual problem that has units, we know these are inches, so we need to include the inches. Need to include units. Okay. Number 4, you saw an advertisement of a TV in the newspaper where it mentioned that the TV is 32 inches high. We know this piece is 32. We also know that this piece is 32. And 50 inches wide. So I know that this piece here is 50. And can calculate the diagonal length of the screen. So I also know this piece is 50. So I take one of these triangles. They're both the same, so it doesn't matter which one. I'm looking for the diagonal piece, the part across from my right angle. I'm looking for my hypotenuse. So this should be 50 squared plus 32 squared equals c squared, which is 2,500 plus 1,224 equals c squared. So when I do all of that, I get that c equals 59.363 inches, which is also the square root of 3,524 inches. So there's the front page. Let's go to the second page. For number 5, we want to draw the picture. If I know you and a friend ran 5 miles north, so here's my 5 miles that I ran. And then I ran 3 miles east. What is the shortest distance to the nearest tenth of a mile you must travel to return to your starting point? Where the shortest distance is just a straight line. So we're looking for this piece here. Here's our right angle. So we're looking for our hypotenuse. We're looking for C. 5 squared plus 3 squared equals x squared. Oops, not 8. 25 plus 9 equals x squared. So we know 34 equals x squared. Square root both sides. We want it to the nearest tenth of a mile. So this would be 5.8 miles. Make sure you are drawing pictures for all of these, because it will definitely help you. Draw your pictures. All right. Number 6, you sailed a ship north a distance of 40 miles, and then east a distance of 20 miles. And we want to find the distance between the start point and the end point. So we're looking for this. 20 squared plus 40 squared equals x squared. And that's 400 plus 1600 equals x squared. So 2000 equals x squared. Square root both sides. And we get 44.721 miles. Next one, you are shopping for a new computer. So here's our computer. And see, a monitor is listed as being 19 inches. This distance is the diagonal distance across the screen. So we know that this is 19 inches. We're looking, if the screen measures 10 inches in height, what's the actual width of the screen? So we're looking for this. We're looking for the bottom. 19 is our hypotenuse, so 19 squared equals 10 squared plus x squared. 19 squared is 361, and that equals 100 plus x squared. So 261 equals x squared. Square root both sides, and we get x equals 16.155 inches. All right, now we're at, given the following measures of the sides which form a right triangle. In order to form a right triangle, we need a squared plus b squared to equal c squared. So we know that c is always our biggest piece. So when I'm looking at these, I want to figure out which one's my biggest piece. Between the 26, 24, and 10, the 26 is my biggest piece, so that's c. And it doesn't matter between 24 and 10 which one's a and which one's b. So I'm saying does 24 squared plus 10 squared equal 26 squared? Looking to see if that's true. 26 squared is 676. We're saying does that equal 526, 76 plus 100? Since these are equal, this is a right triangle. For letter B, the 31 is the biggest side, so 31 is our C. So we're looking at does 31 squared equal 23 squared plus 14 squared? 31 squared is 961, and we're saying does that equal 529 plus 196? Does 961 equal 725? No, this is not a right triangle. The next one, we want to figure out what is the square root of 85. Figure out which one our C is. The square root of 85 is 9.219. So the square root of 85 is my C squared. Where's my C? Because that's the biggest piece. So I'm looking at, does the square root of 85 squared equal 7 squared plus 6 squared? So does 85 equal 49 plus 36? Yes. So it is a right triangle. And last one of this section, we have a bunch of these things. Now we know the biggest one is going to be the hypotenuse. When we have all square roots, you're looking for the biggest number under the square root. And that would be the 63. So 63 is our C. So square root of 63 squared equals square root of 31 squared plus the square root of 17 squared. So that would be, this makes it easy, 63, 31 plus 17. So we get 63 equals 48, which it does not. So this does not form a right triangle. Number 9, which of the following three lengths can be used to form a right triangle? You are selecting 3 values from the list below. These 3 should form a right triangle. Things to keep in mind are your Pythagorean triples. So keep in mind your 3, 4, 5s, your 5, 12, 13s, your 7, 24, 25s. So look here. I know 5 goes with 3, 4, 5, which I don't have. 5 also goes with 12 and 13, which I don't have. 6 and 8 would form a right triangle if I had 10. So I can't use 6. But 7, 24, 25 is a Pythagorean triple. If you don't remember those, just pick sets of 3 to see if they form the right triangle. Another circle which of the 3 form a right triangle. Well, we know 3, 4, 5 form the right triangle because they're Pythagorean triple. 11 is another one. And this one I'm also going to use 3, 4, 5. Because 12 is 3 times 4, 16 is 4 times 4, and 20 is 5 times 4. So this is a 3, 4, 5 special right triangle. Another special right triangle. We know 5, 12, 13 is one of our special rights. 5 times 2 gives me 10. 12 times 2 gives me 24. 13 times 2 gives me 26. Remember these Pythagorean triples, it'll make...
So right now we're talking about our special right triangles. So our 2 special right triangles are 30, 60, 90 and 45, 45, 90. So let's look at the first one we have in 13. So in this problem, this is a 30, 60, 90 triangle, and I'm going to solve this using the ratios. So the ratios for a 30, 60, 90 triangle, 30, 60, 90. Under the 3 is at 1, under the 6 is the square root of 3, and under the 90 is a 2. Now I'm going to place what I know, which is this 10, and it is across from the 90. So I will put that under the 90, making a fraction with the 2. Next, I'm going to find this side I have labeled x. X is across from the 30, so under the 30, I'm going to make a fraction with the 1. Now I'm going to take those 2 fractions and solve for x. So I set them equal. I'm going to kind of move down here for right now. So I have 1 over x is equal to 2 over 10. When I cross multiply, I have 2x is equal to 10. Divide both sides by 2, and I have x is equal to 5. So in your test, the problems will look like this. You will need to write the 5 in the box in the triangle. So now what I need to do is I need to find the other side. I'm going to label that side y. That side is across from the 60, so I find my 60 and I make a fraction with the square root of 3. Now at this point, I have 2 things that I can choose. However, I don't want to use this one because that would give me an x and a y, and I don't want to work with an x and a y. Instead, I'm going to use these 2, and I'm going to set them equal. And after I set them equal, I am going to solve for y. So I have the square root of 3 over y is equal to 2 over 10. I cross multiply and get 2y is equal to 10 times the square root of 3. To get y by itself, I divide both sides by 2. That gives me y is equal to 5 square root of 3. Because this 2 is not under a square root, I divide it only into the 10. And 10 divided by 2 gives me the 5. And again, I need to fit that in my box. 5 square root 3. Moving on to number 14. So again, 14 is a special right triangle, and this triangle is a 30, 60, 90. So I start using my ratio, 30, 60, 90. Under the 30 is a 1, under the 60 is a square root of 3, and under the 90 is a 2. So again, I don't have any variables in this problem. I'm just going to label an x and a y. So let's say I call this side x. This 5 here was given to me, and it's across from the 30. So I go to my 30, and I make a fraction with the 1 that's underneath the 30. Next, I need to place my x. My x is across from the 60. So I go to my 60, and I place my x under the square root of 3 to make a fraction. I'm going to take these two fractions, and I'm going to solve for x. I cross multiply, and I get x is 5 times the square root of 3. Now, in this particular problem, we were given basically an answer bank. So we need to make sure that our answer is in there, and it is. So my x is right there. I'm going to fill it in the triangle. So that's 5 square root 3. From here, I also need to find the other side that's missing. I'm going to call this side y. Y is across from this missing angle, but I know if I have a 30-degree angle, I have a 60-degree angle. All the angles in a triangle add up to 180, which means this angle has to be 90. So my y goes underneath the 90, making a fraction with the 2. So again, when I look at what I have in here, I know I have to use the y. This one has to be used. I've got to use this one, but I do not want to use the one with the x when I'm trying to find y, which means I'm going to use the 1/5 again. So I have 1 over 5 is equal to 2 over y. I cross multiply, and I have y is equal to 10. So I go back to my triangle, and I write 10 in the little space there by the triangle. Moving on to question 15. So in question 15, we have the same style. We have an answer bank, so to speak, and we have a 45, 45, 90 triangle. So 45, 45, 90, and underneath is a 1, and a square root of 2. The first thing I'm going to do is place the number that I was given, and it's across from this blank angle. But again, all of the angles add to 180 in a triangle. So 45 plus 45 is 90. I subtract that from 180, and I get that this angle is also 90. So I go to my 90, and my 16 is going to make a fraction with the square root of 2. Now I need to find x. I'm going to call this side x. It doesn't really matter. And across from the x is a 45. So I find my 45, and I make a fraction with the 1. Now these two fractions I'm going to set equal. And then I'm going to cross multiply. So I have x times the square root of 2, which is silly, but that's exactly what I have, is equal to 16. Now to get x all the way by itself, I need to divide by the square root of 2. And when I do that, I get x is equal to 16 divided by the square root of 2. At this point, I look at my answer choices. So here my answer bank is, and I do not see this answer anywhere. So what I need to do is I need to make my answer look like one in the answer bank. So if I take 16 divided by the square root of 2, and I rationalize the denominator, that means I don't want a square root in the denominator anymore. But the only thing I can do is multiply by a 1, the number 1, but in a silly version. So I'm going to multiply by the square root of 2 over the square root of 2. That number is really just a 1. I can multiply any number by a 1, and it won't change the value. It might change the way it looks, but it's still the same number. And this gives me 16 square root of 2 on the bottom, and the square root of 2 times the square root of 2 is the square root of 4, which is the same as just 2. Now, once I have this, the 2 is not under a square root, the one that's on the bottom, so I can divide the 16 by 2. And when I take the 16 and divide by 2, that gives me 8. So this number is the same as 8 times the square root of 2. Now, the other thing that we can do is we can simply use our calculator. So if we wanted to, we could calculate the value of 16 divided by square root 2. When I calculate that on my calculator, I get 11.313. So I can also come over to my word bank, answer bank, and I can calculate each answer. this answer, 8 times the square root of 2, is actually the same. It's 11.313. Now, I could calculate all the other values, but this is the one that I'm looking for. So, without rationalizing the denominator, I now know that x is 8 times the square root of 2. Now, at this point, we have two options to solve for the other missing value. If you recognize that you have a 45, 45, 90 triangle, which is also the same as having an isosceles right triangle, then we know that two sides are equal. And if you recognize that, then you know that this is also 8 square root 2. And you'll notice there's two 8 square root 2's in our answer bank. The other thing that I can do is call this y, and it is across from the 45. I make a fraction under the other 45-degree angle. And then if I want to find y, I don't want to use the thing with the x. I have a 1 over y is equal to the square root of 2 over 16. Cross multiply. Y square root 2 is equal to 16. Divide by the square root of 2. And I get y is 16 divided by the square root of 2, which is what I just found, and I know that that is 8 times the square root of 2. Moving on to number 16. Again, we have a 45, 45, 90 triangle. So we're going to start with our ratios. 45, 45, 90. Under the 45 is a 1, under the 45 is a 1, and under the 90 is a square root of 2. I'm going to place the 8 across from the 45. So I choose one of the 45's, and I make a fraction with the 1 under the 45. The next thing I want to do is label a missing side with an x, and x is across from this angle. In a triangle, all the angles add up to 180. And if I work that out, I'm going to get that this is 90 degrees. So my x is across from the 90. So I go to my ratios, and under the 90, I make a fraction with the square root of 2. At this point, I'm going to take these two fractions and set them equal to each other, and I cross multiply. And I get x is equal to 8 times the square root of 2. So I go to my answer bank. Here's my answer bank. And I make sure, do I have an 8 times the square root of 2? And I do. This is going to be my x. So I put that in my picture, 8 times the square root of 2. At this point, if you recognize that the 45, 45, 90 triangle is isosceles, then you know that these two sides are equal, which means the missing side is 8. If you did not recognize that, you would call this a y. Notice that it is across from the 45, so under the other 45, we make a fraction with the 1. And then I'm not going to use the x. I'm going to set these two equal. So I have 1 over y is equal to 1 over 8. And that gives me y is equal to 8. And that is in my answer bank. Moving on to 17. 17 is again a 45, 45, 90 triangle. So 45, 45, 90, and we set up our ratios. Under the 45 is a 1, under the 45 is a 1, under the 90 is a square root of 2. I'm first going to place the number I was given, which is a 5, and it's across from the 45. So I find one of the 45's, and I make a fraction with the 1 in my ratios. Now I need to decide what I'm going to find next. So I'm just going to call that side x. This side is across from this missing angle right here. And I know 45 plus 45 plus the missing angle has to equal 180, which means this missing angle is 90. So I go beneath the 90 is a square root of 2, and I make a fraction with the square root of 2. I'm going to take these two fractions and set them equal to each other. I cross multiply, and I get x is equal to 5 times the square root of 2. So I'm going to go back to my picture, and I'm going to put that this is 5 times the square root of 2, making sure that it is actually in my answer bank. Next, if you notice that this is a 45, 45, 90 triangle, that means it is isosceles, which means these two sides are equal, giving me a 5 here. If you did not recognize that, you would call this side y. The y is across from the 45. We go to the other 45, make a fraction with the 1, And we can set these two equal to each other. Sorry, that's supposed to be called y. I wrote down a 5. Make a fraction with these two values. 1 over y is equal to 1 over 5, and y is equal to 5. And again, that is in my answer bank, and that is my y. Number 18, we now have a 30, 60, 90 triangle. My 30, 60, 90 ratios are a 1 under the 30, a square root of 3 under the 60, and a 2 under the 90. I start with the number I was given. That was a 6. It's across from the 60. So I find my 60 and I make a fraction with the square root of 3. Next I need to find a missing side. I'm going to go ahead and call this side x. This side is across from the 30. So I go to my 30 and I'm going to make a fraction with the x. I'm going to set these two fractions equal to each other. And once I've done that, I'm going to cross multiply. So x times the square root of 3 is equal to 6. To find x, I need to divide both sides by the square root of 3, and that gives me x is 6 divided by the square root of 3. When I go and look in the answer bank, I do not see that answer. So I have two choices. I can rationalize the denominator, or I may use my calculator to find what x is equal to, and then find that answer in the answer bank. The first thing I'm going to do is rationalize. So I multiply by a silly version of the number 1, which does not change the value of the number. And by doing that, I choose whatever the denominator is with the square root to create this number 1. When I multiply this together, I get 6 square root of 3 on the top. On the bottom, I have the square root of 3 times the square root of 3, which is the same as the square root of 9. And the square root of 9 is 3. So my denominator is 3. From here, because the 3 on the bottom does not have a square root, I can divide it into the 6. And 6 divided by 3 is 2. So I end up with 2 times the square root of 3. So now I go to my answer bank, and do I have that? I do. My answer bank has got a 2 square root of 3, so I'm going to fill that in my triangle. From here, I need to find the other variable. Oh, I apologize. I was going to show you how to do that on the calculator as well. So if I have x is equal to 6 divided by square root of 3, I can pick up my calculator and figure out what that value is. And when I figure out that, I get the answer is 3.464. So now what I'm going to do is I'm going to look for this number in my answer bank. And obviously 12 is not it. But if you type 2 times the square root of 3 on your calculator, you're going to get that this is the same as 3.464, meaning this is the same as this. Whichever way you find that is absolutely fine. Next, we need to find the other missing side, and it is y, and it's across from this missing angle. But again, all the angles in a triangle add up to 180, so if I work this out, I know that I get 90, so this is across from the 90. So I find my 90, and y makes a fraction with the 2. Now I don't want to deal with the x when I'm trying to find the y, so I'm going to set these two equal to each other. Cross multiply, and I get y times the square root of 3 is equal to 6 times 2, which is 12. To get y by itself, I divide both sides by the square root of 3, and I get y is equal to 12 divided by the square root of 3. So again, I don't have this answer in my answer bank. So I either pick up the calculator and work it out, or I rationalize. Now if I were to pick up the calculator, I get 12 divided by the square root of 3 on my calc, and I get 6.928. So that's what I would be looking for in my answer bank. I have already used this. 12 is not the same as 6.928. I tried the square root of 6 on my calculator, and the square root of 6 is 2.449. So that's not what I'm looking for. 6 times the square root of 2 gives me 6.485. That's not what I'm looking for. 6 times the square root of 3 is 6.928. That's what I'm looking for. So this should be my y value. Let's go ahead and rationalize. So the bottom is the square root of 3. So I multiply by a silly version of the number 1, which is the square root of 3, over the square root of 3. And that gives me 12 times the square root of 3 divided by the square root of 3 times the square root of 3 is the square root of 9, which is the same as 3. So that's my denominator. The 3 on the bottom does not have a square root, so I can divide that into the 12, and that gives me 4 times the square root of 3. So again, I know 4 times the square root of 3 is this side. Number 19. We have several problems involved in number 19. I'm going to start with the one on the top left. So right here, and again we have a 45, 45, 90 triangle. So using our ratios, we have 45, 45, 90. Underneath the 45 is a 1, underneath the 45 is a 1, and underneath the 90 is a square root of 2. I'm first going to place the 10. The 10 is across from the 90, so under the 90, I make a fraction with the square root of 2. I'm going to call this side x, and this side is across from a 45, so under the 45, I'm going to make a fraction with the 1. I set these two fractions equal, and when I do, I get x times the square root of 2 is equal to 10. To get x all the way by itself, I need to divide both sides by the square root of 2, and my x is 10 divided by the square root of 2. There are other ways to write that. You may leave it like that, or if you rationalize the denominator, you will get the answer 5 times the square root of 2. Either answer is fine for this problem. Now at this point, if you recognize the triangle is 45, 45, 90, you'll notice it is isosceles. So for this side here, should be the same as the x we just found. So it's either 10 divided by the square root of 2, or you could have written 5 times the square root of 2. Either answer is fine. If you did not recognize that, then you need to place the y under the 45. Now we need to solve for y. I eliminate the x, I don't want to see it anymore, and then I write my fraction 1 over y equal to my fraction, square root of 2 over 10. I cross multiply. Y times the square root of 2 is equal to 10. Divide both sides by the square root of 2, and I get y is equal to 10 divided by the square root of 2, which is what I had found for x. I'm now moving on to the top right. This triangle is also a 45, 45, 90. So my ratio is 1, 1, square root 2. First thing I'm going to do is place my number. My number is across from the 45. So I'm going to use one of the 45s, and I'm going to place the 15 to make a fraction. Next, I need to choose a side to be x. I'm going to call this side x, and this side is across from the 90. So I take the 90, I put my x under the square root of 2. I'm going to take these two fractions, and I'm going to set them equal to each other, and solve for x. And I get x is equal to 15 times the square root of 2. And I'm going to place that into the box on the side of this triangle, 15 square root 2. Now, at this point, if you recognize, we have a 45, 45, 90 triangle. It's isosceles, and these two sides are equal, and you can write that this is just 15. If you did not notice that, then you would put a y here, which is across from the 45. So I use the other 45, and I make a fraction with the y. At this point, I'm not going to use the x fraction. I'm going to set these two equal to each other, and when I cross multiply, I get y is equal to 15. I am moving down to the second one on the left. This is a 45, 45, 90 triangle, and the ratio is 1, 1, square root 2. First thing I'm going to do is place the number that I was given. That was a 17, and it's across from the 45. So I choose one of the 45s, and I make a fraction with the 1. Now I need to call one of these sides an x. I'm going to go ahead and call this side an x. It's across from the 90. So I choose the 90, and under the square root of 2, I put an x. I'm going to set these two fractions equal, And when I cross multiply, I get x is equal to 17 square root 2. So I'm going to go ahead and fill that in the picture. This empty box is 17 times the square root of 2. Now at this point, if you recognize that this is a 45, 45, 90 triangle, it is isosceles, and these two sides are equal, you can simply write the 17 right here. If you don't notice that, you would call this side y. It's across from the 45. I go to my 45, I make a fraction with the y. I no longer want to use the x, the fraction with the x, so I'm going to set these two fractions equal, and y times 1 is equal to 17 times 1, and y is 17. I'm now moving over to the second one on the right, and this triangle is a 30, 60, 90. So I start with my ratios, 30, 60, 90. Under the 30 is a 1, under the 60 is a square root of 3, and under the 90 is a 2. The first thing I'm going to do is place my number. My number is the square root of 3, which is across from the 60. I choose the 60, and I put a square root of 3 underneath the square root of 3. Next, I need to pick a side to call x. I'll go ahead and call this side x. This is across from the 30. So I go to my 30, and I make a fraction with the 1. I'm going to set these two fractions equal, and that gives me x times the square root of 3 is equal to square root of 3. And then to get x all the way by itself, I divide by the square root of 3. That may look silly, but it's just the number 1. Anything that makes a fraction, top and bottom is the same number, is a 1. So that tells me that x is a 1, and I can fill that in my diagram. Next, I have another side called y. Y is across from 90, and I go to the 90 and I make a fraction with the y. Now, I'm finding y, so I don't want to deal with the x, so I'm going to get that out of my diagram, and I'm going to cross multiply these two. So I have a square root of 3 times y is equal to 2 times the square root of 3. I divide both sides by the square root of 3 to get y all the way by itself. And when I do that, I get y is equal to 2. So I place that into my diagram. On to the next page. I'm continuing number 19. I am at the top left. I have a 30, 60, 90 triangle. So 30, 60, 90. My ratio under the 30 is a 1, under the 60 is a square root of 3, and under the 90 is a 2. First thing I'm going to do is place the number I have been given. It's across from the 90, so I go to my 90 and I make a fraction with the 2. And then I need to label one of the sides as x. I'll call this side x. It's across from the 30, so I go to my 30 and I make a fraction with the 1. I'm going to take these two fractions and set them equal to each other. So I have 1 over x is equal to 2 over 10. I cross multiply and I get 2x is equal to 10. I divide both sides by 2, and that gives me x is equal to 5. I place the 5 in the diagram in the box for that side. I have another side I need to find. I'm going to call that side y. Y is across from the angle that is 60. So I go to my 60 and I make a fraction with the y. Now that I'm finding the y, I don't want to have anything to do with the x. So I'm going to eliminate the x, and I'm going to set these two equal to each other. When I cross multiply, I have 2y is equal to 10 square root 3. To get y all the way by itself, I divide both sides by 2. That gives me y is equal to 10 divided by 2 is 5 times the square root of 3. I go to my diagram and I put that in the box. I'm now at the top right. This is another 30, 60, 90 triangle. So I start with my ratio, 30, 60, 90. Under the 30 is a 1. Under the 60 is a square root of 3. Under the 90 is a 2. I start with the number that I've been given. It's across from the 30. So I go to my 30 and I make a fraction with the 1. Next, I need to call one of the sides x. I'm going to call this side x. X is across from the 60. I'm going to set these two fractions equal to each other and cross multiply. x is equal to 9 times the square root of 3. I'm going to place that in my diagram in the box where x is. Now I have another side I need to find, which is y. Y is across from the 90, so I'm going to place it underneath the 90, making a fraction with the 2. I have already found my x, so I'm going to eliminate that from my ratios, and now I have two fractions left. 1 over 9 will be equal to 2 over y. When I cross multiply, I get y is equal to 18. So I put that in my diagram. Number 20. For number 20, I don't know what I have going on. So let's read what we have. Given one side, that must be that, of the equilateral triangle. Equilateral triangle means all the sides are equal. This whole side is also 9. Find the length of the altitude. So I need to put an x somewhere in my picture, and I don't have that right now. The altitude is the height, which is this segment that goes from the top straight down to the bottom. Now, I still don't know much of what's going on. What I do know, though, is in an equilateral triangle, all of the angles are equal. Equilateral triangle means all the angles are also equal. If all the angles are equal, and they have to add up to 180, that means all of these angles have to be 60. Now, I am looking to use a right triangle, and I have a right triangle. My right triangle is right here. That's the triangle that I want to use. So, up at the very top, this angle is going to take the 60, it's going to be cut in half, and that makes this angle 30. So what I'm going to do to help myself out is I'm going to draw just the highlighted triangle that I have all by itself. Now I know this is 90, this is 60, this is 30, and I know my 9 is right here. And again, my x is this. So now I have a 30, 60, 90 triangle. My ratio is 1 square root of 3, 2. I'm going to place my number first. That goes under the 90. So my 9 goes here. My x is across from the 60. So my x goes underneath the 60 under the square root of 3 to make a fraction. I take those, set them equal, and cross multiply. I have 2x is equal to 9 times the square root of 3. To get x all the way by itself, I divide both sides by 2, and you're welcome to leave your answer just like that. 9 divided by 2 times the square root of 3. You can also write that as 4.5 times the square root of 3 as well. Moving on to the problem at the right. So this is the same as the one that we just did, so we know some things already. We know that we have a 30, 60, 90 triangle, and we know we're trying to find the altitude, which is right here. So I'm going to draw that triangle out by itself. X is here, 30 is here, 8 is here, and 60 is here. Now we have a 30, 60, 90 triangle, so we use our ratios. We're going to first place the number. The number is across from the 90, so my 8 is going to go here. My x is across from the 60, so my x is going to make a fraction with the square root of 3. I'm going to set these two equal and cross multiply. I get 2x is equal to 8 times the square root of 3. I divide both sides by 2, and I can divide the 8 by 2, and that gives me 4, and the square root of 3 is still there. So my altitude is 4 times the square root of 3. Number 21. We now have a square. We know a couple things about a square. We know all the sides are equal. If these two sides are equal, we have a 90-degree angle right here. We have an isosceles triangle. That means these two angles have to be equal as well, making them a 45-45 degree angles, and we have a 45-45-90 triangle. Now, I haven't labeled in my picture what I'm trying to find yet, so let's read the question. We need to find the length of the diagonal. The diagonal goes from corner to corner in the square. So there's my x. It's across from the 90. So I make a fraction with the square root of 3. My number was 17. It's across from the 45. So under the 45, I put a 17. I set these two equal to each other, and I get x is 17 times the square root of 3. Number 22, we have a 30, 60, 90 triangle. And again, we have an answer bank. So under my 30 is a 1, under my 60 is a square root of 3, and under my 90 is a 2. I'm first going to place my number. My number is across from this angle. I don't know it, but 30 plus 60 plus whatever that angle is has to add up to 180. If I work that out, that's going to give me 90. So my 14 is across from the 90. I'm going to place my 14 under the 2 to make a fraction. Next, I'm going to pick a side that I'm going to call x. X is across from the 60. So under the 60, I place my x. I set these two fractions equal, and I get 2x is equal to 14 times the square root of 3. From here, I divide both sides by 2, and I get x is equal to 14 divided by 2 is 7 times the square root of 3. So I go to my answer bank, and I find 7 times the square root of 3. That's my x. I'm going to place that on this side of the triangle. Next, I have another side that I want to find. I need to place a y in my figure for the other side I'm trying to find. It's across from the 30. So I find my 30 and I make a fraction with the y. Now to solve this, I don't want to use the fraction with an x. So I'm going to use the 1 over y equal to 2 over 14. I cross multiply and I get 2y is equal to 14. To get y by itself, I divide both sides by 2, and y is equal to 7. I go to my word bank, and I find 7, and so I place that on the triangle. Next page. Number 23. So number 23, we have this triangle, and we have these three angles that we want to place somewhere. All we know is these sides. So what I know is this is the biggest side, and across from the biggest side, this has to be the biggest angle. So I come over here and I find the biggest angle. That's 70, which means this has to be the 70-degree angle. Next, I'm going to move to the middle side. When I move to the middle side is the 15 feet. So for the 15 feet, this is the middle side. Across from that will be the middle angle. The middle angle is 60 degrees, so I place my 60 here. At this point, I can be finished, and I know 50 is the only one left, but that's the smallest side, and it's got to be across from the smallest angle. Moving on to 24. We're listing the angles in order from greatest to least, so I want the biggest angle goes first. The biggest angle is across from the biggest side. Here's my biggest side, so across from that is the biggest angle. So angle 7 is the largest angle. Next, I need to find the middle side. The middle side is going to be 35. Across from that will be the middle angle, which is angle R. Finally, I need to find the smallest side. The smallest side is the 23.7, and across from the smallest side will be the smallest angle, and that's angle T. Number 25, we're listing the sides in order from greatest to least. So what I want to do is I want to find the greatest angle. So the greatest angle is right here. This is the biggest angle I have. Across from it is the biggest side. This side is called RT. So this is side RT. Next, I want to find the middle angle and find the middle side. The middle angle is R, and across from that will be the middle side, which is this side called ST. So ST is the middle side. Next, I want to find the smallest side. So I need to find the smallest angle. This is the smallest angle. Across from that will be the smallest side, and that side is called RS. Number 26. 26, we have three angles, and we are trying to list the sides of the angle, the sides of the triangles from largest to smallest. Well, the first thing I need to do is I need to figure out how big is each angle. I don't know that right now, but I know all the angles add up to 180. So I'm going to take my 4x plus 6 plus 2x minus 10 plus 3x plus 13 and set that equal to 180. This will allow me to find x. I have a total of 9x plus 9 is 180. I subtract 9 from both sides, and I get 9x is equal to 171. I divide both sides by 9, and when I divide by 9, I get x is equal to 19. Now that I have x is 19, I need to take the 19 and I need to replace my x right here. So on my calculator, I'm going to do 4 times 19 plus 6, and that's going to give me that angle J is 82 degrees. I move on to K, and again, I know x is 19. So on my calculator, I'm going to do 2 times 19 minus 10. That gives me 28 degrees. Moving on to L, I replace x with 19. On my calculator, I do 3 times 19 plus 13. That gives me 70 degrees for L. At this point, it's very important I draw a diagram. So I need to draw a triangle, and I'm going to label them with J, K, and L, and I'm going to fill in the angle measures that I just found. J is 82. I know that K is 28. And I know that L is 70. Now I need to actually reread the question and figure out what am I trying to do. I want to list the sides in order from largest to smallest. So I want the biggest side first, and then I want the middle side, and then I want the smallest side. So to find the biggest side, I need to find the biggest angle. So I start with the biggest angle, and across from the biggest angle is the biggest side. This side is called KL. To find the middle side, I need to find the middle angle. The middle angle is 70. Across from the 70 is JK. So that's my middle side. Then I need my smallest side, that's across from the smallest angle, and across from the smallest angle is JL. So here are the sides listed in order from largest to. We are now on question 27. Now, 27 has all these words, but there is no diagram. So the first thing that I need to do is draw myself a diagram. So I draw myself a diagram. This is going to be a triangle, and I have angle A is 65 degrees. I have angle B is 15 degrees. And I have angle C is 100 degrees. So from here, I need to answer the question. I want the sides to be in order from, excuse me, shortest to longest. So I'm starting with the short, and I'm going to the longest. So let's start with the short. The short side is across from the smallest angle. So here's my smallest angle. Across from that is this segment, and that is segment CA. Now, this is a multiple choice question, so the other way that this could be written is it could be called AC. So basically, I'm looking for either CA or AC. When I go to my answer choices, I can already eliminate answer choice H and answer choice G. Moving on, I want the middle side. The middle sized angle is 65. Across from that is this segment called CB. Now again, it could be called BC, either one. So I can go to my answer choices, and at this point, I can actually select the answer. The answer is going to be this one right here, but let's go ahead and finish the problem out. The long side is across from the long angle, the big angle. This is the largest angle. Across from that is segment AB. So AB or BA is the longest side. Next page. Question 28 has 3 different problems. Each one is multiple choice. Now, if we look at this first triangle, we can see we have 2 angles. But we know that all the angles have to add to 180. So 30 plus 62 plus x is equal to 180. When I solve that by taking 180 and subtracting 30 and subtracting 62, I get this last angle is 88 degrees. So I need to place the 88 in my triangle. From here, I'm going to answer the question. Question is, I want to list the sides in order from least to greatest. So I want to start with the smallest side and then go to the biggest side. So I start with the smallest angle. Here's my smallest angle, and the side across from that is the smallest side. So that is GJ. It's also known as JG. So at this point, I should be able to go to my answer choices and eliminate some. So I'm looking for GJ or JG, which looks like I only have one answer choice remaining. I'm going to go ahead and make sure that this is correct. The next biggest angle, yes, is G, and across from that is segment HJ. So HJ is my middle segment, or JH, and does that match? It does match with my answer choice. And finally, I have my largest angle, and across from that is my longest side. This side is called GH, so GH is the big side. It could be called HG. So I want to make sure that is right there. The next question in question 28, again, we are missing an angle. So the first thing I need to do is I have to figure out what this angle is. So 51 plus 56 plus x is going to be 180 degrees. So I take my 180 and I subtract out 51 and I subtract out 56. That leaves me with my angle measure that's missing at 73 degrees. Now again, we are going from the smallest side to the largest side. So to do that, I start with the smallest angle. So the smallest angle is right here, D, and across from that, the side is called EF. It also could have been called FE. So I can go look at my answer choices, and I can already choose my answer choice, which is right here, but I'm going to go through and make sure that this is correct. So move on to the next biggest angle, which is 56 degrees. The side across from that is the middle-sized length side, and that will be DE, which could also be written as ED. When I look at my answer choices, that is the middle side. Finally, I have the largest angle, and across from that should be the largest side. That side is called DF or FD, and when I look at my answer choice, it is correct. Moving on to the last part of question 28. We have another triangle missing an angle. So I know that 62 plus 41 plus x has to be equal to 180. So I take my 180, I subtract out 62, I subtract out 41. That leaves me with the missing angle is 77 degrees. And again, I'm going from smallest to biggest. So I take the smallest angle, which is 41 degrees. The side across from it is called QR. You can't see the Q, but it's right there. So my smallest is called QR, which could also be called RQ. So I go to my answer choices, and it looks like my answer should be A. I'm going to go through and do the rest of the problem. R is the middle-sized angle. Across from that is QS. That's the middle-sized length side. That could also be SQ, and it is the middle. The largest angle is the 77, and across from that is the segment here, which is RS. So RS is the largest side. It could also be called SR. Question number 29. Circle which 3 lengths can create a triangle. So there's a couple ways to do this. One is to just kind of go along the way and figure out, well, can these 3 lengths make a triangle? So for example, first of all, I can't have a length of a triangle be 0, so I can eliminate that one. Now, in order to create a triangle, if I add the two smallest pieces, that has to be bigger than the big piece. So in the circle right there, I've chosen 1, 2, and 3. If I were to add 1 and 2, I would get 3, but 3 is not larger than the biggest side, which is 3. So these three sides cannot form a triangle. So I move on. And again, you don't necessarily have to go in this order. I'm going to move on to 2, 3, and 5. When I look at 2, 3, and 5, I take the two smallest, and that should be bigger than the biggest. 2 plus 3 is equal to 5, and that is not bigger than 5. So these three lengths will not form a triangle. I'm going to move on. The next three I'll try are 3, 5, and 7. When I add the two smallest, is that bigger than the biggest? Well, 3 plus 5 is 8. Is 8 bigger than 7? And it is. So I have found the three lengths that will create a triangle. Now, this is not the only answer, because let's try another set. If I were to look at the next set of sides, 5, 7, and 10, if I take the two smallest and add them together, is that bigger than the biggest? 5 plus 7 is 12, and 12 is bigger than 10, so these three will also form a triangle. Additionally, they do not need to be three lengths that are next to each other. It just so happens in this problem that the three lengths that create a triangle are next to each other. So let's move on to number 30. We have two lengths are 4 and 6. Which segments below could be used to create a triangle? There are two correct answers, and you must circle both. Well, in this one, I could go through and check each one, meaning I could compare the 1, the 4, and the 6 if I was checking to see if 1 inch will work. I would add 1 and 4 and decide, is that bigger than 6? In this case, it is not. And I could go through that and do that with each of these choices. What I'm going to do, however, is I'm going to find the range of values for the third side. So to find the range of values for the third side, I start out with this, and I need to fill in the blanks. The first blank is when I take the two sides that I have, and I know that if I subtract them, that the third side has to be bigger than 2. So I know I have to be bigger than 2. So immediately I can get rid of 1 and 2. 2 is not bigger than 2. For the other end of the inequality, I will add my 6 and 4, and that gives me 10. This tells me that it has to be, the third side has to be smaller than 10. So now I go over here, 12 is bigger than 10, 10 is equal to 10, which means here are the two choices that will create a triangle. And what that means is if I have the 3-inch, a 4-inch, and a 6-inch segments, those will create a triangle. Additionally, the 4-inch, the 6-inch, and the 8-inch together will create a triangle. Number 31, there's two different ways to solve that one. I'm going to use the range of values method. So if I have these two sides already, the question is, can the third side be 40 meters? Well, I'm going to do exactly what I just did. So for the first one, I'm going to subtract the two numbers, and 26 minus 15, that is going to give me 11, which means that the third side must be bigger than 11. That says than. Next, I need to add the two sides I've been given, and when I add the 26 and the 15, that gives me 41. And the third side has to be smaller than 41. So 40, does that meet the requirements? Is 40 bigger than 11 but smaller than 41? And it does. So first I need to answer the question, can the third side be 40 meters? That's a yes or no question. So the answer is yes, because 40 is between 11 and 41. Now, if you write that, the work here has to be shown. Okay? And again, that's not the only way to solve that one. That's just the method that I chose. Number 32, we have two sides of a triangle are 17 and 17. Write an inequality to identify the range of possible values for the third side, x. So we have this situation going on again. So starting with the first value, I would subtract the 17 minus 7 and get a 0. Now, this is actually okay. It just means that the third side has to be any number bigger than 0. It could be a half, it could be a fourth, it could be 15. Moving on to the other end of the inequality, we add 17 and 17, and we do that, we get 34. So this is our answer, that x is between 0 and 34. Next page. Number 33, we have two sides of the triangle are 2 feet and 1 foot. Write an inequality to identify the range of possible values for the third side, x. So I start by writing my inequality, and I'm going to fill in the blanks. For the first blank, I subtract the 2 lengths I've been given, and 2 minus 1 is 1. So that means x has to be larger than 1. For the other end, I add the 2 and 1, and that is 3, and that tells me that x has to be smaller than 3. Number 34. You should have seen something like this in class, and so what we are doing in this one is we need to match up Marcus, Tanya, Nicole, Stephen, and John with each one of them gets one of these pieces of wood from the table, and everyone needs to make a triangle. I am going to do this using the range of values. So I'm going to set up my inequality for Marcus. Marcus has to be between 6 minus 2 is 4, and 6 plus 2 is 8. So Marcus has to be, the side that he needs has to be bigger than 4 and smaller than 8. So when I go to the table, bigger than 4, nope, bigger than 4 and smaller than 8, yes, bigger than 4 and smaller than 8, not smaller than 8, not smaller than 8. So that tells me that Marcus has to have the 7-inch side, and I can fill that in down here. Moving on to Tanya, I'm going to do the same thing. I'm going to write her an inequality, and she has to be between, I subtract 11 minus 5, and that gives me 6, and then I add 11 plus 5, and that gives me 16. So that tells me for Tanya, the piece must be bigger than 6, and it has to be smaller than 16. So I go back to the table. I know that 7 is no longer an option, because Marcus has that one. And 3 is not bigger than 6. 10 is bigger than 6 and smaller than 16. 11 is bigger than 6 and smaller than 16. And 15 is bigger than 6 and smaller than 16. Now I'm going to erase the work that I have, so that I can write down what the options are for Tanya. So Tanya's could either be the 10 or the 11 or the 15. Moving on to Nicole. Nicole has to be between what two numbers? So I'm going to come to the other side. And the first number is going to be 9 minus 4, which is 5. So Nicole's piece of wood has to be larger than 5, and 9 plus 4 is 13. The piece must be smaller than 13. So I come over to the table and I figure out what pieces could possibly work for Nicole. Well, 3 is not bigger than 5. 10 is bigger than 5 and less than 13. 11 is bigger than 5 and less than 13, and 15 is not less than 13. So we either have the 10 or the 11 for Nicole. Moving on to Stephen. Stephen's are 3 and 5. So for his inequality, we have 5 minus 3. So x has to be bigger than 2, and 5 plus 3, which is 8, and it must be smaller than 8. So we come back to the table, and we can identify which pieces are an option for Stephen. So for Stephen, the side has to be bigger than 2 and smaller than 8, and the 3 will work. The 10 will not, because 10 is not smaller than 8, the 11 is not smaller than 8, and the 15 is not smaller than 8. So that means Stephen has to have the 3-inch plank. I'm going to remove it from the table, and Stephen's is the 3-inch. And finally, we get to John. John, I'm going to put over here. His third piece must be between 12 minus 2, which is 10, and 12 plus 2, which is 14. So I need a plank that is bigger than 10 and smaller than 14. So again, I come to the table and let's figure out what are the options for John. So is 10 bigger than 10? No, that will not work. Is 11 bigger than 10 and smaller than 14? Yes. Is 15 bigger than 10 and smaller than 14? No. So the only one that will work for John is the 11-inch plank. Then we can now move up to Nicole. Well, if John has the 11-inch, that means Nicole cannot use the 11-inch. She must use the 10-inch. At which point, we can now move on to Tanya. The 10-inch is being used by Nicole. The 11-inch is being used by John. So the 15-inch plank is the only one left for Tanya to select. Now each person has a wooden plank that will create a triangle with the pieces they've been given. Question 35. So we have a set of possible lengths for a triangle. And then we have to place them, whether we have a 30-60-90 triangle, a 45-45-90 triangle, a right triangle, but it's not 30-60-90 and it's not 45-45-90, a triangle, but it's not a right triangle, or these three sides don't make a triangle at all. So the things that I would start with is I would probably start with B. Now for B, for a 45-45-90, we know that our ratio is 1 square root of 2. So somewhere there has to be a side that has a square root of 2. So let's go to my answer choices, and the only one I have with that option is right here. And would that fit to have a 5, and a square root of 2, a 5 square root of 2 here, and that would. Those ratios would all be equal. If you cross multiply them, you get the same thing. So I have an isosceles triangle because it's 45-45-90, two sides are equal. That's the 5 and the 5. And then I have a 5 square root 2. The next one I'd probably look at is the 30-60-90. So for the 30-60-90, we know the ratio is 1 square root 3, 2. So I would be looking for something with a square root of 3. When I come over, there's only 1. So does it fit the ratio 12 square root 3, and 24? If you were to cross multiply any of those fractions, they would come out to be true proportions. So this is the 30-60-90 triangle. So next things we're looking for are a right triangle, a triangle but it's not a right triangle, and something that's not a triangle at all. Now from here you can go any way that you would like. So if we started with this one, we can see if it's a right triangle. The largest side is 5, so that'd be my C. So I would be checking, is 3 squared plus 4 squared equal to 5 squared? And that is 9 plus 16. Is that equal to 25? And 25 is equal to 25. So this one is actually our right triangle. 5, 3, 4. So the next one we're looking at is this 6, 6, 12. So the question is, it's not a right triangle. I just have to decide, is it a triangle? If I add the two smallest sides, that should be bigger than the biggest side. Is 12 bigger than 12? The answer to that is no. This is not a triangle. So that would go right here. Finally, we have this last one. And let's just check and make sure that this is a triangle. I add the two smallest sides, and is that bigger than the biggest side? And 20 is larger than 12. Now I could also check with Pythagorean theorem to decide if it's not a right triangle, but this is not a 45-45-90 triangle, which would need to be if it had two sides equal. This is the end of the review. Please feel free to go back to any problem that you need if you have other questions. Good luck on your test.